Alright, so hello guys, welcome back to another problem video. Today we have another question here, and as always, let's first start by reading the question. So, let A, B, C, D be a parallelogram, okay? Now we draw on the diagonal AC, a circle, and then we draw in a diagonal AC, and a circle is going to be drawn inside ABC, tangent to all three sides, and touches AC at point P. So now let's look at the first part, okay? So prove that DA plus AP is going to be equal to DC plus CP. So how are we going to solve this? Well, I'm gonna put in some new points here. So these points are going to be X and Y. I'm going to put X right here and Y right here. Now the important part you need to realize about this is that AP is going to be equal to AX. Why is this? Well, because this question is actually going to be using a lot of tangents. We see here that the lines AX and AP are both tangent and they both meet at the same point A, external of this circle. And so that's how we know that these two sides are the same. It's just a formula, right? And we need to use this formula a lot, or formula/theorem a lot. So from here we can see that AP is going to be equal to AX. And similarly, BX is going to be equal to BY. And also, CP is going to be equal to CY. So this means that if we look at AD here, which is the side of the parallelogram, we can see here that AD, which is one side of the parallelogram, is going to be equal to CY plus YB, which is the other side of the parallelogram. Similarly with AB and DC, we can see here that DC is going to be equal to AX plus XB. And so this means that DA plus DP, DA plus AP is going to be equal to CY plus YB plus AX, because AP and AX are the same, as I said before. And this is going to be equal to CP plus BX plus AX. And since BX and AX is going to be equal to AB, which is also going to be equal to DC, we can then turn this into CP plus DC. So in other words, DA plus AP is going to be equal to CP plus DC. So this is how we solve the first equation and how we prove in part A that DA plus AP is going to be equal to DC plus CP. Now let's look at part B. So part B is, let's read the question first. Draw in the line, when drawing the line DP, a circle of radius R1, a circle of radius R1 is drawn inside the DAP. So this circle here, and DAP is tangent to all three sides, and a circle of R2 similarly is going to be drawn into triangle DCP, which is also tangent to all three sides, and it's going to have a radius of R2. So now we need to prove that the radius of 1, okay, so radius 1 divided by radius 2 is going to be equal to AP divided by PC. So in order to solve this, we can see here that the area of these triangles, so ADP, the area of ADP and the area of PDC, their ratio is also just going to be the ratio of AP to PC. Why is this? Well, it's pretty simple. We can see here that they both share a base on the same line, and we also see that their height is the same, right? Their height is from point D to it's just the bisector, so from point D, it's bisector down to AC. So here we can write down that the area of a triangle ADP, divided by the triangle of the area DPC is going to be equal to AP divided by PC. And the reason why this is important is because we can find out the area of ADP and DPC. How? Well, we can use the radius. So I'm actually going to draw a few new points here. And a couple of lines as well. O, L, Q here. H, M, and N. Oh shit, I drew too many. Okay. So we can see here that the area of triangle ADP here is going to be equal to 1 over 2 times R1, and then times AD plus DP plus AP. And then similarly for triangle DPC, it's the same thing, but with different radiuses and sides. Now you might be asking how I got this. Well, it's actually pretty simple as well. So I'll explain right now. Let's look at, for example, let's look at this triangle here. Let's look at triangle D to the center of this to P here. So as you can see here, I'll draw this out. This triangle here. It's a little bit messy, but you'll be able to understand. As you can see here, the area of this triangle here is going to be dp multiplied by the radius divided by 2. And you can do this for all three of the triangles in this circle using the radius multiplied by the respective bases. Okay, this line's a little bit off, but yeah. Because we know that the radius is going to be perpendicular to the tangent line. And we know the tangent line on the bottom here is also going to be perpendicular to it, and also it's also going to be the base of the triangle. So the sum of ADP, the area of ADP, is just going to be the sum of these three smaller circles, which we can use the radius to find the area of, which is this. Now something we can also see here is that, well, we have DA, so or AD here, DA, AD, whatever you want to say, and also AP here. And over here we have DC and CP. And in part A, we literally just said that DA plus AP is going to be equal to DC plus CP. So we already have two things, two variables in both of these three things that are going to be equal to each other, and they also both contain dp as well. So this means that this here, so this ratio here, this is going to be equal to. I'll rearrange it now. Give me a second. Right, and as I said before, we see that dp and dp here are going to be the same, and obviously DA and AP, this is AP not AD, DA and AP and DC and CP are also going to be similar from part 1 or part A of the question, and so this is how we know that we can just cancel these out, and also cancel the 1 over 2's at the start to receive R1 over R2. So in other words, AP over PC is going to be equal to R1 over R2, or as the question states, R1 over R2 is going to be equal to AP over PC. So that's how we prove this. So now let's look at part C. I actually printed out another paper because we didn't have enough space. So obviously I redrew the graph here, and now let's solve for part C. So as always, I need to first draw out a couple of points here. So I'll just repeat the ones from the last graph. So these points are going to be pretty simple. Simple. So obviously Q, O, L from the last question, H, M, and N, and then X and Y up here. So the question here is, suppose that DA plus DC is going to be equal to 3 times AC, and DA is going to be equal to DP, which we already know. So let's let R1 and R2, actually no, sorry, DA and DP that's given to us. Now let's let R1 and R2 be the two radii defined in B. So we need to determine the ratio of R1 over R2. Now we know that the ratio of R1 and R2 is just going to be AP over AC over PC, and we will use that later on. So actually I'll write it down here. Let's let AP be equal to A, and PC be equal to B. And so this means here that AC here, AC is just going to be equal to AP plus PC, or A plus B. And so this means that DA plus DC is going to be equal to 3A plus 3B, because it's just going to be 3 times A plus B, or AC. So now over here, I'm actually going to write something out here. Let's let DA plus AP, so it's going back to the first part of the problem, be equal to DC plus CP. We already know this actually. And let's say this is going to be equal to S. Now we're using S as a placeholder variable here, so we can see here that DA is going to be equal to S minus AP, or S minus A, and that DC similarly is going to be equal to S minus CP, or PC, and it's going to be equal to S minus B. So here we have D, dA, and dC. So let's rewrite that into S minus B and S minus A to receive 2S here. Minus A minus B is going to be equal to 3A plus 3B. And so this means that S is going to be equal to 2A plus 2B, and therefore dA and dB, dA and dC. So dA is going to be equal to A plus 2B, and dC is going to be equal to 2A plus B, as we just plug in S from here up into here. So now that we have that here, we can see here that dP is going to be equal to dA is going to be equal to A plus 2B as well. Now the reason why we're going to do this is because we're going to look at cosine angle DAP and cosine angle DAC. So DAP would be this angle, and DA and C, which is also going to be this angle, and we're going to compare them using cosine law. So this is going to take off a lot of space, but we can see here that cosine angle DAP is going to be equal to cosine angle DAC. And this is going to be equal to, let's go over here to DAP. We know that from cosine law, it's just going to be dA squared plus AP squared minus dP squared over 2 times dA times dP times AP. And then we'll repeat the same thing with cosine DAC, right? So this is going to be equal to dA squared plus AC squared minus DC squared divided by 2 over dA times AC. Oh, the truck in the background. Okay? And now we're going to rewrite this with A and B. That's why we just did this part. So we're going to use all of these lengths in A and B. So now we can rewrite this into A plus 2B squared plus A squared minus A plus 2B squared divided by 2 times A plus 2B times A. And this is going to be equal to A plus 2B squared plus A plus B squared minus 2A plus B squared. And this divided by 2, this is going to be divided by 2 times A plus 2B times A plus B. So this is a really big mouthful. And now what you can do here is now we can solve for this. So solving for this, we can finally receive, I'm going to skip this step, because this takes forever, into A plus B. So in order to solve this, you would do 2 things. You can either do cross multiplication, or you can do this times this is going to be equal to this times this, and then you can solve for A divided by B. And we can see here that A divided by B is going to be equal to 4 over 3. So the answer to this question is going to be 4 over 3. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.